So welcome to our TechEd session, the Central Data Integration and Data Science platform of Endress+Hauser. I am Kussmann, Senior Consultant for Business Analytic Applications, and we also have Stephan with us. Stephan, do you want to introduce yourself?
Yes, of course. My name is Stephan Wernli. I'm a data scientist and I'm working at Endress+Hauser Flowtech, Switzerland.
So today we will start with a short introduction of the company Endress+Hauser and your speakers again, and then we will shortly have a deep look at the data integration and data science platform at Endress+Hauser. This is then followed by one of our projects or use cases which we implemented, and after a short demo we will then give you a short outlook of this project and upcoming projects with our data integration and data science platform. Let me quickly introduce Endress+Hauser. Endress+Hauser is available for you around the world, whatever you're doing, whenever you're drinking or eating or you're taking a pill. All these things are manufactured with process automation technology. And this is the field of Endress+Hauser. So Endress+Hauser is a global provider of measurement instrumentation, services and solutions. And we provide our products in the whole world. We have dedicated sales centers that are available for our customers around the world. They are responsible for the sales, the service and the engineering. And then in addition to that, we also have a few main production centers. The production centers produce our products in the major economic regions in the world and are responsible for the production, the research and development, and the marketing for our products. Besides that, we have other support centers like our support center in Rheinach in Switzerland. They are responsible to ensure all our processes are running with the best quality. And also we have one central IT service provider that is responsible for our IT system landscape. So everyday life involves a wealth of products manufactured with process applications provided by Endress+Hauser, and we help our customers around the world to run their applications, their plants safely, efficiently, and reliable. Your today's speakers, as we introduce ourselves, are Stephan Wernli, data scientist for global sourcing at one of our main production centers in Switzerland, and I am Kussmann, senior consultant for applications business analytics at the central IT service provider here in the group. Let's deep dive into the topic. When we talk about our data integration and data science platform, we internally speak about the data science workbench. We all know that the demand for data is growing rapidly. We have many data analysts, we have data scientists that need data to do their job and to answer the urgent questions we have in the world. And also we know that the speed of the development of analytic applications is as fast as it never was before. How do we want to tackle that at Endress+Hauser? At Endress+Hauser, we have a system landscape with many SAP systems. For example, we have our ERP systems in which we run all our processes. We also have one centrally operated data warehouse to which we extract all our data from the ERP systems mainly. But we also have the SAP Cloud Platform, which is used to implement integration use cases or projects, for example, for a corporate website or web shop. Correct. And for example, the SAP Cloud Platform uses data from our business data lake, which is based on the SAP HANA database in the cloud. And here already many data assets from our company are stored. Besides that, we also have many backend services in place, or we also use the SAP Asset Intelligence Network for our IoT devices. Not less important, we also have many non-SAP systems. And here we come to one of our main challenges. In case of non-SAP systems, we have, for example, our Salesforce CRM system, we have a global supplier platform called Jagger, or we use a Snowflake cloud data warehouse, which is mainly used by our data scientists. So the challenge here is, how do we get access to all these different databases or data silos, and how do we allow our analysts and scientists to get this running, to combine the data and to develop their own digital products? For that, we rely on the business technology platform, which is mainly the tool SAP Data Intelligence. So we use the SAP Data Intelligence to orchestrate the data from all our systems. This can be the SAP systems or the non-SAP systems. And within that, we develop our own products. We use the machine learning tooling, or we use the data orchestration and integration tooling to get to know which data we have and what can we use and whom to ask to get access to that. And if it comes to the visualization or the presentation of our results, then we use the SAP Analytics Cloud or, for example, SAP Lumira. In our opinion, when we talk about the current world in which we work, then we think there are the two main problems. The first one is the infrastructure, which we need to tackle with, or which we need to try to tackle with the data science workbench. If you don't have one common infrastructure to work on for these colleagues, the data scientists and data analysts, then you're getting lost. Because normally, and especially in a company like Endress+Hauser, which is quite decentralized, these colleagues sit in different companies, different departments, different countries or continents. So it's very important to get them together and to get them on one platform and to allow them to work on our data. If you wouldn't have one platform to work on, then they always use their own tools and prototypes wouldn't get into production or wouldn't allow us to get them productive in a production system and get them running. They would stay as prototype. So this is our data science workbench. So let's talk about a real world use case. Here you can see one example of our products. And you can see that, yeah, this is a measurement instrument, but also this measurement instrument or measurement device consists of many, many different components. And if you would now go to our web shop and you would try to configure one of these products, you would directly see that the options you would have are immense. So there are many, many options which you can choose for one product. Normally, Endress+Hauser doesn't sell any product which is the same as any other product. So it's like you would configure a car. You have many, many options. So for us, it's very crucial to know what we use in our final product. We have many, many raw materials and many, many assemblies, for example, and this is very important to us to know which one of these are sold to which customer and to know the effects. So for us, we want to answer the questions, what are the relationships of our final product and the materials we use for the production. We need to know how complex these products are, what kind of materials are built in, which components are used, and how does that influence, for example, our sourcing strategy. Do we have any products or do we have any supply chains that may be at risk? For example, if one of our suppliers has problems, which products does that affect? If you have so many components and so many options to choose for one product, then it's very difficult to answer that question. And this is what we want to solve or to answer with the product Artificial Intelligence for Supply Chain Risk Analytics. This product is executed at the Business Technology Platform. Here we use the SAP Data Intelligence, and from a technical perspective, we wanted to tackle 4 main challenges. The first one is data scientists like Stephan. They already developed many, many code and defined prototypes and worked on prototypes, but they did not get them running in production, for example. They need a sustainable system to work on. So we need a fast transition from a prototype to a final product. And as I said, the orchestration of disjoint data is one of the other challenge. In our use case, we need to combine data from our ERP or SAP BW system with data from our supplier and sourcing systems, or at the end of our CRM system. All this data needs to be brought together and then to develop our final product. And of course, this final product needs then to be easily integrated in our current system landscape, and we would need high computation power for the execution of our implementation. Especially for us, if we want to know what kind of materials and which components are built in our final product, then we need to do a bill of material explosion. So we need to execute a resolution of our bill of materials to get to know which components are used in our end product. And for that, as it is a recursive problem, we would need a lot of high computation power, for which we want to leverage the SAP Data Intelligence. Okay, let's see our minimum viable product, which is current status of our project. As I said, we first need to do the bomb explosion. So we need the data from our SAP ERP systems This data is already transferred via ODP to our SAP BW. Both systems are located in our local ENH Endress+Hauser network. And besides that, we use the SAP Data Intelligence, which is deployed in our SAP Cloud Platform. And within the Data Intelligence, we store the results of our data in the SAP HANA. What we also already use is the SAP Analytics Cloud, which is used to then present the results and create dashboards for. And how it is connected at the moment, the SAP Data Intelligence is connected via the Cloud Connector. So we extract the data from the SAP Business Warehouse system via an OData service. The data is then extracted and stored and used in the SAP Data Intelligence. There we execute our bomb explosion and store the result in the SAP HANA. The SAP Analytics Cloud at the end then consumes the data from the SAP HANA system. There we developed a calculation view that combines different tables and makes it visible for the SAP Analytics Cloud. Enough theory, let's see what Stephan can show us in his demo.
In this demo, we will show you the practical example how we unwind the bill of material and gain insights about our component structure. Firstly, we talk about the general idea of this graph, the given input and the expected output. Secondly, we take a detailed look at the graph. A graph contains all the logical steps of a data pipeline and the used operators. And the last point, I will speak a little bit about optimization, but first, let's start with the basic idea. Like mentioned before, the graph unwinds the product structure of Endress+Hauser components and shows the basic materials that were used. In the first step, data is needed that shows the relationship between different materials and assemblies. After that, we need to classify automatically which materials are final products, so we can use them as an input for the following resolving. With these pieces of information, the structural lists and the array of final products, we can create a function that gave us what we need. The last layer of a resolved bill of material so that we can identify the purchased parts for the following risk analysis in the future. After the resolution is done, we will save all the created information in a HANA table. Let's take a look at how we realize this idea. On the left-hand side of the screen, you see the OData query consumer. This will be needed to fetch the relationships between assemblies and materials. This operator will fetch all requested data from the BLW query and transmit it to the CSV producer that you can see here. This CSV producer creates a file. This file is also important for the optimization of the graph, but more on this topic later. In the first custom Python operator, create top material list, we have two main things that happens. First, we will create a list of all top-level materials as a set, so we know which material are final products to resolve. Second, we will check the status of the load balancing architecture. If the architecture is ready, we will cut the list of top materials into 128 equivalent pieces. So I can show you quickly the code here. Here you see the architecture check if the workers are ready in the single pots. And here you see if the input data is sorted right. And here you see also the cutting and the event that is responsible for the sending of the messages. So what's happened now is like described before. We will now send the top materials to resolve to the worker in the graph. This worker will load the relationship information from the generated file before and starts to resolve the given material numbers. The group in the middle that contains the worker nodes runs with a multiplicity of 16. So we start 16 individual pots that grab automatically the incoming task. The incoming task in this case are the cutted material list parts and save the results in the HANA table on the right hand side. Is this process finished and the check batch counter receive all 128 sent out requests to the worker, the graph will terminate and the task is done. Let's talk a little bit about the last point, the optimization of this graph. We optimize this graph mainly with two things. Firstly, we look for the network traffic and the fetching of incoming data. So we think it is the best idea to persistent this file so that we have this network traffic just one time. So if the graph is starting, all informations will be fetched, a file will be created, and if we use this file or this relationship information later in the groups are not responsible to pull it directly from the database. They can just read it from the file, so it's in memory. Secondly, we try to get this round-robin architecture that you see over here so that the system is load balanced. Load balance means that you can use the system in a very static way so that it's always at a good amount of CPU and GPU load.
I hope you enjoyed our demo and we were able to show you the implementation process of this specific use case. I would now like to show you some further improvements we are aiming for in the future to increase the benefit of this project. At the moment, recursive resolution only provides the basis for the further analysis. As already mentioned, it enables us to identify the purchased parts of the final products. In order to further increase the benefit, the data sources shown down below will be connected and the resolved components are enriched with additional information. Example, environmental risk or political and structural conditions in the region where supplier is located. We also want to improve the current pipeline and its architecture. For example, the OData connector you can see here will be replaced by a direct BW connection. But enough about this project. I would now like to briefly introduce our use case roadmap for further activities. Here you see a selection of further activities we would like to implement with the SAP DI. This includes the integration of interfaces and services which we will realize by our own operators, the analysis of correlation of stock markets, packages and industries' influence for sales planning, the improvement of demand and sales planning at general purpose, and the automated classification of status changes of documents in the SAP systems to support our R&D department. What we can say after the implementations of some use cases with the SAP DI, the SAP Data Intelligence allows us a fast transition from notebook to an industrial pipeline. And this is really important. I think this is one of the most valuable purpose of the product. Then we are able to connect different data sources and things really easily. The Kubernetes architecture allows us a strong parallelization and scaling. That's also really important for the industrial usement. And then we are able to use an open and flexible architecture. Where we think there's room for improvement, the collaboration at the moment is not really comfortable for ML and pipelining development, and the syntax checks can be improved, especially in the coding operators like Python or R. I think we are at the end of our presentation. Simon and I thank you for your attention, and we hope to see you in the Q&A session. Thank you.
Woo!